about linear inequalities. So a linear inequality is kind of like a linear equality, but just greater than or less than or equal to. So maybe a linear equality would be something like 2x plus 1 equals 5. And to make that an inequality, then we'd make it like 2x plus 1 is greater than 5. So we can solve that like the same way as we usually do. Like subtract 1, you get 2x is greater than or equal to 4. And then divide by 2, and you get x is greater than or equal to 2. So you plot that on the number line is you just write 2 here, and we're starting at 2, and we go bigger than 2. So like maybe 3 would be on this side, and 1 would be on that side. Now, if we had something like, if the answer came out to be something like x is just greater than 2, if it were not, x is greater than or equal to 2, then we would plot that similarly, but we would have an open circle around 2 to say that 2 is not something that we can plug in for x here, because 2 is not greater than 2. 2 is greater than or equal to 2, but 2 is not greater than 2. So that's why this would have an open circle. Let's see. So there's one thing that you gotta watch out for in inequalities. It's mostly the same as solving inequalities, but there's one little catch that will throw you off if you're not expecting it, and that is, well, let's just work an example and see if you can find it. So let's do 1 minus x is less than 5. So we'll just subtract 1 from both sides. Negative x is less than 4, and then just multiply by negative 1 and get x is less than negative 4. And we'll plot that, negative 4, right here, and then we can have anything on this side of it. So let's take negative 5, for example. When we plug that should work for x, right? Well, 1 minus negative 5 is that less than 5? No. 1 minus negative 5 is like 1 plus 5, and that's 6 less than 5. That's not right. What just happened? So what's actually happening is whenever you multiply or divide by a negative number in these inequalities, you have to flip the sign. So right over here, instead of keeping this as less than, we should have flipped this to become x is greater than negative 4. And then the image here would have been still at negative 4, but going the other way. I'm just going to scribble this out. And if we take something like negative 3, that's on the bigger side of negative 4, we plug that in, 1 minus negative 3 is less than 5, then 4 is less than 5. And that works. Now you might be wondering, like, why is that? That seems like witchcraft, or just seems weird that it doesn't work out, that you have to flip the negative sign just because you multiply by negative. Why is that? Well, I can't really give a good explanation of why that is so much, but a really simple example of it would be 1 is less than 2. But when you multiply by -1, you get -1. So that's -2. That's not correct. -1 is bigger than -2. -1 is greater than -2, I should say. And so you need to flip the sign. So this should be -1 is bigger than -2. Actually, maybe there is a good way to think about this too. Like, if we draw a picture, we can actually kind of see what's going on. So here's 0, here's 1, here's 2. So 1 is originally we're going 1 is less than -2. But when we multiply by -1, this -2 goes all the way over here, and this 1 goes all the way over here. So the thing that was originally bigger actually ends up going smaller. Originally it's further away from 0 in the positive direction, but then you multiply by -1, and it's still further away from 0, but in the negative direction, which makes it smaller. So that's what you can, maybe you can think about this image when you're doing it, or you can just think about this example, or just remember to flip the sign, whatever works for you. But yeah, that's the one thing that'll screw you up in inequalities if you're not paying attention for it.